All right, so let's move on to number 5. This one says, suppose that for your oven, the core temperature of brownies right after being taken out of the oven is normally distributed with a mean of 351 degrees and a standard deviation of 3 degrees. All right, so it says write down the correct notation and symbols for the 351 degrees and 3 degrees reported in the problem. Why did you use these symbols? So it says suppose that for your oven, right? So for you probably have the same many other people out there, right? There's a whole bunch of people out there that own the same oven that you do, and for your model of oven, the mean is 351 and the standard deviation is 3 degrees. So this is a population mean. So we're going to say the mean is 351 and the population standard deviation is 3. Okay, so I chose those because they're population parameters. If they had come from a sample, then I would be using X bar and the lowercase s. All right, so make sure you're paying attention to those symbols. There'll be a question or two on there about using the correct symbols. All right. So part B says find the probability that a brownie will have a core temperature of less than 343 degrees. And so remember they told us this thing was normally distributed here. So we have a normal distribution. Let me draw a picture of that. And we're calculating a probability here. So we're going to be using a normal CDF here. So I'm going to mark my center. So there's my 351. And we want to know what's the probability of being less than 343. So 343 is over here to the left of the mean, and we want to be less than, so we're shading all of the area to the left of the 343. So we're going to say normal CDF. And we're going to do a negative 1E99, comma 343, comma 351, comma 3. Right, so it goes left bound, right bound, mean, standard deviation. Then we go to our calculator and crunch the numbers. We go second bars, normal CDF. We have our negative 1E99 in there already. We're going up to 343, means 351, and standard deviation is 3. There we go. So we got 0.004 if I go to 3 decimal places. All right. That completes that problem. Pretty easy, just a basic run-of-the-mill normal CDF problem. All right, so it says find the probability that a brownie, that's important, you'll see why in a minute, right? A brownie, one brownie, will have a core temperature of more than 350 degrees. All right, so again, this is still dealing with a normal distribution. And if you remember in class, I would always ask you to draw this curve with your mean drawn in, and then you shade the appropriate area, right? So we want to be more than 350, so let's say 350 is over here, just to the left, and we want to be more than, so we're going to be shading all of this area to the right. So this is going to be a normal CDF going from 350 to 1E99 with a mean of 351 and a standard deviation of 3. Here we go. Second bars, normal CDF, and we're going to go 350 up to 1E99. So we got 0.631. There we go. Right, try another one. All right, so find the probability that a brownie will have a core temperature between 345 and 355. All right, so again, same distribution. With the center at 351. And we're going to be in between 345, which is over here, and 355, which is over to the right. And we want to be in between those, so we're going to shade everything in between those two values. There we go. And we'll do a normal CDF. 345, comma, 355, comma, 351, comma, 3. So that is our calculator input. And we'll do second distribution, normal CDF, 355, Let's see what we get. So we got 0.886. There we go. All right. Now this one says find the probability that a dozen. Right. So we're no longer dealing with the probability that a randomly chosen brownie or a single randomly chosen brownie. We're now taking 12 brownies, calculating the mean of those 12 brownies, and trying to find the probability that the mean of those 12 brownies is less than 350 degrees. So this is a sampling distribution. Okay? And they're sneaky like that, right? They just kind of sneak that in there. They don't tell you, hey, this is a sampling distribution problem. You've got to recognize that when you read the problem. Okay, so again, our mean is 351. We want to be less than 350. Okay, so here's my distribution. And we're going to do a normal CDF, right? Because the sampling distribution is still going to be normal because the population was normal. All right, so even though the sample size is not greater than 30, it doesn't matter because the original population was already normal, so we can do this. We're going to go negative 1E99. We're going to go up to 350. The mean is going to stay the same for a sampling distribution. It's the same as the population, but the standard deviation does change. So this is going to be a standard deviation of 3, and we have to divide by the square root of 12 to correct for the new variation in this distribution. So when I go to my calculator and make sure that I type that in. All right, so negative 1E99 up to 350. And then we go over here, we do 3 divided by the square root of 12. There we go. So we got 0.124. There we are. All right. Last one here. So find the probability that a dozen brownies will have a mean core temperature between 348 and 352. So again, this is sampling distribution, but it's still normal. Still has the same center. We're going to go in between 348. Let's say 348 is right about here, and 352 is over here. And we're going to be in between, so we're shading everything between those values. And I'm going to set up my normal CDF. This time going from 348 to 352. This should be a 351. And then our standard deviation of 3 over root 12. Here we go. So 348, 352, 351's in there, the 3 over root 12's in there, and enter. We got 0.876. All right, so that does that. That is that's the end of that problem. And we're going to move over to number 6. Now, it says you notice that 28.6% of the time that you make a frozen pizza, you end up burning it. I mean, it's a ridiculous problem, but I mean, no one really keeps track of how often they burn a frozen pizza in the oven, but it's all in good fun here, right? So it says out of 30 frozen pizzas, what is the probability of burning 10 of them? So this is actually a binomial experiment, right? You put the pizza in the oven and you're either going to burn it or you're not, right? We have a set number of trials at 30. So we can say n equals 30. The probability of success, right? We call that P. The probability of success is 0.286. And they just want to know what's the probability of burning 10 out of 30 of them. So this is definitely a binom CDF problem. So we're going to do a binom. Actually, this is a binom PDF because we're looking at the probability of burning exactly 10, right? So when you go to your calculator, you're going to go to second vars. We'll go down to the one that says binomial. And we're going to do binom PDF. And again, it just wants to know your trials, which we've already stated was 30. The probability of success was 0.286. And the value that we're interested in finding the probability of is 10. And we get a probability of 0.130. Okay. So we go to write down the calculator command, number of trials, probability of success, and the number that you're finding the probability of. And we got 0.130. So let me read the next one, right? So same exact problem. All the parameters are the same still. Out of 30 frozen pizzas, what's the probability of burning less than 7? So whenever you see a less than, right, or a more than, or a between something, that's an indicator that you're going to switch over from PDF to CDF. All right, so we're going to be doing a binom CDF for this one. All the parameters are still the same, so we're still going to do 30, 0.286. But what the CDF does is it starts at 0 and it's going to add all of the probabilities up to the number that you specify. So since we want less than 7, we want to add up all the probabilities from 0 to 7. So CDF adds those up for us. So we want to make sure that we say, hey, go ahead and go up to 6 because it says less than 7 but not equal to. Okay, so we're going to add up everything from 0 to 6, and that'll be everything that is less than 7. Okay. Go down. Binom CDF. Trials are 30. Probability is still 0.286. And we're going to be adding everything up to 6. So we've got 0.203. So the probability of burning less than 7 of them is about 20%. Right, so out of 30 frozen pizzas, what's the probability of burning more than 12? All right, so we're going to do it. This is going to be another binom CDF. And we're going to do binom CDF 30, 0.286. That all stays the same. But because we're doing a more than, right, so we want to add everything up after 12, right? So we went from 13 all the way up to 30 for this distribution. All right, so what binom CDF does is it adds everything up to the number that I specify. So if I put a 12 here, binom CDF is going to add everything from 0 up to 12. So everything that it doesn't add up is going to be 13 up to 30, which is what we want. So we need to do 1 minus the binom CDF whenever we see more than. All right, so 1 minus fixes that problem for us. All right, so we're going to go here, we're going to do 1 minus, and I'll go to distribution, go down to my binom CDF option. And everything stays the same. I'm going to change the x value to 12 here. And we get 0.060. So the probability of burning more than 12 is about 6%. It means you probably won't burn more than 12. Most likely, I don't understand who's burning 28.6% of their pizzas, and it's crazy. You'd think you would figure it out, especially after 30 trials. So it says, let x be a random variable representing the number out of 30 trials of frozen pizzas that are burned. Find the mean and the standard deviation of x. Yeah, that's no problem. So if you look through your notes, before we went on this extended spring break of ours, we talked about quick ways to calculate the mean and the standard deviation of a binomial distribution. And the mean was real simple. If we just do the number of trials times the probability of success, that was the same thing as an expected value, and that would give us our mean. And then the standard deviation was just like it, but it was NPQ. So you do N times P times Q and put that all in a square root. Okay, so NPQ is actually the variance. The square root gives you the standard deviation. So you can calculate that pretty. So I'm going to go to my calculator. Remember, N was 30, so I'm just going to end up doing 30 times 0.286 here. And I'll go to my calculator and type that. So 30 times 0.286. And we got 8.58. So this number that we just got, that's like the expected value. So if this probability is actually correct, if we ran 30 trials, we would expect to burn about 8.5 pizzas. All right. The variation, right? So we would say 8.5 pizzas, you know, plus or minus what? Like what's a typical deviation away from that 8.58? So this is going to be 30 times 0.286 times 1 minus 2.86 or 0.286. And that's all going to be inside of a square root. And we can go to our calculator and calculate that. I'll save you the key presses here. If you do it correctly, you should get 2.475. Right, so you would expect to burn about 8.5 pizzas, and a typical deviation away from that 8.5 is about 2.5 pizzas. All right, so there you go. These would be handy formulas to remember if they ever do ask you to find the mean or standard deviation of a binomial distribution. Right, so these are worth memorizing, and you never know when it pops up. All right, guys, that's it for part 2. Hopefully this video was helpful for you. Tune back in for part 3. I'm hoping to get it done either Thursday night or Friday morning. All right, guys, take care.